This is a magnetic accelerator, and this is the coil. This is a AC to DC converter, which steps down 240 volts to 12 volts. It induces current to the coil, which is around 10 meters long. We called it up around the plastic tube. This is the push button to initiate the current to shoot the metal projectile. This uses the left-hand Fleming left-hand rule, which is there's force, magnet, and the current itself. When using the Fleming rule, it shoots the metal projectile out. For example, it's like this. It's quite weak because we didn't call. It's not really coiled that much yet. For the process, as you can see, we have coiled up 10 meters-ish copper wire around the tube. So in the process of making this, we actually struggled a bit in the coiling part. We didn't know how to coil it properly and neatly, and where to coil it. So firstly, we found a metal rod, and we just coiled our wire there. It was pretty meh, so we decided to just buy a straw, and it was kind of flimsy. So now we have a tube, and fortunately it still works and it shoots like it should. So to shoot properly, the end must be at the edge of the coils, and the timing must be perfect. Well, in this case, human reaction won't make it, so for now it's manually done.
Okay, so the applications of this accelerator are, as you can as you have seen already, it makes metal things go fast. It can accelerate anything from this size or any smaller thing than the coil. So what are the applications of this? Well, besides shooting like warfare things, you can use it in the future if it's scaled up bigger, because it can actually scale bigger. You can actually use it for like delivering payloads into orbit, or like transportation systems such as trains. You can put in like a tube filled with people, and you can make it go really fast from a tube, that kind of thing. Now, but the struggles with scaling this up are the power requirements for powering this, because even at this small scale size, it is using already 10 amperes and 12 volts or even more, and it only accelerates it a bit. Potentially, when you scale it up to be much bigger, it will require a much larger power draw, accompanied with the larger resistance due to the length of the coil required. So in the future, if you will want to scale this up, or should this technology be scaled up, other better conductors will be required in order to make this a possibility. Which is why, as of right now, there are no technologies involving coil levitation or acceleration yet. However, there is an alternative technology called rail-induced magnetism, but that is for another topic.